Hi, my name is Krishna Maran. This is my Physics Lab 5 report. So I did my lab on pendulum system, and there was an object on the pendulum swinging back and forth. So my lab was to find the position of this object as it changed and constantly calculate the angle from the length of the rope. Therefore, I plotted a position versus time graph to observe the angular velocity and the angular acceleration of the object on string. I solved for the angular acceleration, the angular velocity, and theta as it changed while the object on the pendulum was moving a total of two cycles, because that's how long I used my tracker video for, because I could get enough of the data from just 2 complete cycles. So the acceleration was a negative g divided by the length of the string times a sine theta, and the theta is the angle between the string and the vertical. Then for the angular velocity, it was the current velocity plus the angular acceleration we just solved for times dt, and dt is the time interval between every data point. So in this case it was 0.0018, because that's how much time it was between each point in the tracker data. Then to find the angle, it was theta plus the angular velocity we just solved for times dt, which, like I said just now, is 0.0018. So as you can see here in the graph is the position versus time graph, but it is the y position versus time graph. That's why it is a negative, because it is below the axes. So as you can see, it changes at around the same pace because it is a pendulum, so it'll have the same change in position every peak and trough. So that's why the position versus time graph is pretty accurate from the code as to the tracker video. And then as you can see in this text box below, it shows the final angular acceleration and the final velocity, which are 0.29 for the angular acceleration and 8.98 for the angular velocity at the end. Now for the code. So for this code, I called the ball on the pendulum the bob, and I set an initial position and I set the radius of the object, and I made the color blue. And then for the string of the pendulum, I called it rod, and I called the position of it pivot and the axis of it bob's position subtracted by the pivot, and then I gave it the radius of how long it was, and the color of it was red. And then the time initial was 0, and then dt was 0.0018, as I said earlier. And then the length of the string was the magnitude of the initial position of the object subtracted from the position of the origin, which is pivot. And then I calculated cosine theta, since that is just the y position of pivot subtracted from the y position of bob, or the object, and then I took the inverse of that to find theta, and then I set the initial angular velocity to 0 since it starts from rest. And then as you can see below that, I have the code for the graph, which is the y position versus time graph. And then in the while loop below that is where I calculated for the angular acceleration, angular velocity, and theta as the object was moving throughout the pendulum in the 2 cycles. And then I printed the acceleration and the velocity. Then I updated the position of the object with the vector sine theta for the x direction, and then the pivot in the y direction minus cosine theta for the y direction, and then 0 in the z direction. And then to update the other end of the rod of the pendulum, I did the position of the object minus the position of the rod. And then to update time, I just did time plus the time interval is equal to the new time. So with all this, I was able to calculate a predicted position versus time graph pretty accurately.